No, this board is my Microscope stage controller. So to answer your question, you should check one of my previous videos where I showed this 3-axis controller. But basically, we have a Tinsy microcontroller and a TMC 429 ramp generator, and then this chip, which I will soon solder and show how it works, sends out an instruction to each of these drivers here, and then whatever 3-axis construction you have, you can control it with this board. You will see it later on, but we will have some buttons, joystick, and even USB connection to control the wall stuff. So yeah, this is not yet an ADC board, but this is more like a high performance 3-axis stepper motor controller, as I wrote it on the PCB as well. But yeah, one of my very recent videos is about this board, so check my videos if you get bored here. So yeah, so far I'm just removing the pins after soldering. I just decided why not live stream it, maybe some people have some questions or something. We can check together, otherwise this is just a boring task. So why not try to make it fun, right? So this one is done. Not super ugly solderings, but could be better, sure. And it's a good thing that the legs are magnetic, so this is how you quickly collect the garbage. Easy. So we need more resistors here and here. It's a bit too shiny. Maybe you see it better like this. So here I can install 3 LEDs that will drive the RGB LED, and then here we have just the status LED for the power. So those are these guys here. So let's install them. And to answer your question, actually, yeah, if you program this in a way that it follows what you instruct it to do, then yeah, sure, it can be used for focus stacking. But again, I have another video where I actually built a focus stacking PCB. So you might be interested in that. So again, just go wherever my videos are. I don't know if you are checking this from the browser or from mobile, but just go to my channel and you can use the search function and just search for focus stacking, and you will find a bunch of videos on that topic, because I carefully discussed, or tried to carefully discuss focus stacking and stuff, and how my circuit works. And actually that is one of my most popular PCB designs so far. So it seems that it helps photographers around the world. I got some emails and stuff, and they seem to appreciate that circuit. So yeah, but yeah, this can be also used, and actually you can focus stack in 3 dimensions, if that makes any sense. But yeah. So while I'm here, I just install the LED. So since we have a blue board, why not install a blue LED? And then we have an RGB LED as well. And let it sit like that. So yeah, but yeah, coming back to the question of focus stacking, this is more like, I have a microscope. Again, there's a video about it, and I got a fancy stage from a friend who actually will receive this board, and this is especially made for that stage. So I can set the Z position to a higher or lower position, and then I can navigate on the stage along the y-axis and x-axis, and yeah, just that's that. It's quite simple. But let's solder more for fun. It's hot. Oh, long time no see. I see your message now. I hope you enjoyed that paella. It's a delicious stuff. So I guess you are somewhere in the or on the Spanish beach. But yeah. Well, here it is raining right now, so I cannot really enjoy the sea. And yeah, even though I live close to the coast, but this is the, let's call it cold kind of sea. You don't really want to go there unless it's a really hot summer, which we don't really have here in Sweden. And this seems to be free of shorts, but maybe with a little flux I will touch this later on, maybe. And that drags a bit longer. And clean up with the magnet again. Cool. So now we have the LEDs, we have the resistors, basically all resistors. These are 4.7K resistors. They are just pull-up resistors. These are for switches and buttons. And then the LEDs, obviously, to regulate the current, both for this and this guy here. And that's that. So tiny bit ugly, but they don't touch, so it's fine. And regarding these white stains, I will remove them with isopropyl alcohol once the whole board is done. So yeah, this is getting there soon. We can try inserting the sockets. I have prepared them here, so let's see. So these are regular pin headers, the female type, 14 pins, so they will be used for the teensy. And now I want to just show off my trick again. As you can see, this will pretty much fall off. So how should I keep this in the board so I can actually solder it? I made a short video about this thing, but you can have this thing. Its original name is BlueTech, but as you can see, this is white. But if you search for BlueTech without the E in the word blue, then you will find this. It's any office supplies shop will have this, and you just simply stick it. So I shake it like an idiot, but you can see that it stays there, very stable. The only thing you have to be careful is that not to heat up the board close to it. So a good idea is to fix this thing in the center first, soldering it, and then you can remove it. Because if it gets hot, it gets a bit more viscous, so it flows easier, and that's not necessarily good. Of course, if it cools down, you can just use this big blob and just wipe it off. But let's avoid heating this thing up. So it's like that. Yeah, Heftmassa. Huh? But those who don't live in Sweden or don't speak Swedish, they might not understand it. But yeah. I wonder if I can zoom. Oh yeah. Look at these guys. You can have a follow-up zooming here. So this will look a bit better, I guess. Wow, from Peru. That's far away, kind of. Greetings. I guess it's just morning over there. So, good morning. And regarding the brand of this sticky thing, this guy here, I have no idea, but I think it's Prit. I can check it, but let me solder this thing first. Ah, 7 in the morning on Sunday. Oh, I would sleep until like 10. So I hope nothing woke you up. So there we go. Okay. It's hard to see the camera because it's overhead, so I hope you see an acceptable image of this thing. I often browse Reddit, and there is a thread where people ask about their soldering, and most of the time they mess it up. So those who struggle with soldering, I can have a little tip. My soldering is not perfect either, but I think I'm fairly okay with soldering. So what you should do is that you first just put the soldering iron touching both the hole where you have the metallic ring and the leg of the component. So you preheat them, and then you push a little solder there just to have like a small soldering. And then since the leg is also hot, then it will essentially suck in the solder, the molten or melted solder. And then it's done. And just add a little at a time so you don't overdo it. It's not necessary. And then that's that. How difficult it can be. And as I said, I'm no expert in soldering, but I'm fairly okay soldering. I can prove it by showing it. So you see there's no excess solder, maybe even there's too little at 2 pins, but no, not super bad as you can see. And then you can remove this, no residues. Let's remove this guy as well, no residues, so easy. So then I guess I just continue with the other pin. Here we go. Here we go. So there and there. And I will not put anything here because I'm not using that pin row in this circuit. So it's enough to have it like this. So back to work, I guess. So let's see. I wonder if I can zoom even more without sacrificing too much quality. I hope it's good enough. Should be fine. So let's go. So once again, touch the leg and the connection on the pad and then heat it. And then the same rule applies everywhere. Oh yeah, and don't remove the soldering iron immediately as you touch it with the solder. Let it work a little bit to really heat up everything, and then let the solder melt, obviously. That's the main purpose of soldering. So we melt the metal here. Let it go in. The surface tension will pull it into those crevices, and then it's good. And the last pin is there. Done. So that's easy, I guess. Not super bad. It's acceptable. So now you can see that the board got hot there. We have clumps of this there, but just push it back and it will pick it up. There's no worries. Voila. There is no more residues. And then this guy also. So let me zoom out. Done. So now the microcontroller has its socket, but we have more here. So that's easy. Then just keep soldering. I'm going for this row here. Done. Then we move on to the next one. Yeah, by the way, yeah, there are not so many viewers, but if you have any questions or want to discuss anything, just type in the chat. I try to both talk and work at the same time. Some people say it's not efficient, but here we trying to have fun, not efficiency. So yeah. It's good enough, both rows. So this is done. So while we are here, I can install this IC socket and these two pin sockets. But I need to fetch some parts. So I don't really have the 2-pin of this guy, so I just typically destroy them. As you can see, I already sacrificed a few parts. So we need 2 pins there. That is for the feedback of the ramp generator. So that's that. So obviously this is not elegant as well, but I did not bother buying all these parts. So this is messed up, so try again. Yeah, the leftover from the other, this should be fine, I guess. Just trim the edges. Try not to overdo it. There. This is not a beauty contest anyway here with the soldering and stuff. It just has to be functional. So yes. Zoom in. And then these two guys here. It's there, sitting there, it's good enough. And then socket for the IC. So let's do a proper work, fix it at 2 corners, and then it will be here. Here. So it's getting there. So I think it's relatively easy to fix these 3 pairs of connectors. They are already here in the package. So yeah, let's just do the dirty job. Just to make it straight, we can cheat like this. Easy as that. And then you need a better view, I guess. Part placement machine, what do you mean? It's here. Yeah, a pick and place machine would be nice, but then this wall board should be SMD instead of through hole. But my original idea with this board was to make it reproducible by others who don't have too much patience with SMD components, or they don't want to order the PCB with assembly services because they just simply cannot afford it. And I think in here you only need a bit time, and then you can just have fun while assembling it. Or yeah, you can have fun if it works, but if you follow my instructions, which is on my website for this project, then you will be successful. But actually, yeah, I saw some clips with pick and place machines for through hole components like these. That's quite fancy, but I'm happy to have a desk where I can assemble these things. So yeah. So let's move on to the next 2 pieces. I don't recall that packaging right now, but give me a moment and I will look at it. So I will see if I have ever done that, but that sounds familiar. So maybe I have done it. Let's see. That should be a 5-pin chip, isn't it? Like a op amp, 3 legs on one side and 2 legs on the other side, or something like that. Am I correct? Six-pin SOT23. Let me Google that because I know. Yes. Those are tiny. Probably I have those somewhere. Let's focus on my disassembly first. I mean, I'm telling it to myself because I literally have the boards or parts on my left side, so not too far, but I'm pretty sure I have that kind of chip somewhere. But yeah, that's not for the faint-hearted. But yeah, hand soldering assembly components. I would say I can go down to 0603. That is like relatively easy by hand. You just need a good tip and a good pair of tweezers. 0402, yeah, that's getting heavy and difficult. And nothing below. I don't even design any circuits with those. But sometimes, especially if I have some microcontroller-based circuit, like my recent ADC thingy, this guy, then I actually need 0402 sized packages because, for example, the inline resistors for the USB line, they have to be small. Otherwise, I just cannot fit everything on the board. Yeah, without PCB. Yeah, sure. If you have like a, let me see, like these kind of boards, and let's say prototype on this, or you have those pure boards where you have a copper layer on the top and you have to carve your traces in it yourself. Sure. Then it's a nightmare. Yeah, I understood that you meant something like that to hand solder it. That way it's... Oh. Sorry for the noise. Yeah, so here you can see that I messed up a bit because the thing got soft. So it went here. But yeah, no worries. And then the last one. This is so annoying to install, but it's almost done. It's just so meticulous work. So that's done. And let's zoom in. But actually, regarding the hand soldering of SMD components, which type of tip you use? Because I noticed that it's not necessarily this very pointy, which is the best, but there is a like chisel shaped, kind of chisel shaped. I will show it after I finish this row. And those are a bit better for soldering along small parts or around small parts. Because yeah, this is pointy, but the very pointy end where it should be hot, it's not always hot. So then what I do instead is that I have another chisel shaped tip, and I would rather use that if I hand solder, or heat gun. That's just hot air going out, and then it's done. Yeah. I could hold these connectors by their legs. Yeah, sure, but it's just annoying. And then I just found this glue thingy better. But I used to do like that. And also when I soldered these resistors, then obviously I used the bending technique. Just pick up one more leg here. But yeah, now this is done. Let me see the tips. I actually have a box of these. Oh yeah, I got it. And we have this pointy one here, but that's not necessarily the best. Yeah, you use what is better for you. But sometimes these wedge or chisel shaped are a bit more better for SMD, or even this guy. This one, because the end of it, you can see that it's a bit like a chisel. And just for you, if you want to see which type is this, T12 BCI. It's very good that nothing is visible, but let me figure this out. Are they too big? We can check after I assemble this circuit. I can stay a bit for checking it, if you are curious, of course. Or we can take that up in another live session. But yeah, now we have these things. So the previous board has pin headers all over the place, and I'm going to do the same. So first I will just chop up this guy, the pin header, the male pin header, to have connectors all over the place. So I'll just keep this upwards, and then we first, if I have noticed that I skipped one resistor, so let me fix that. So I have this guy here, and we need a 1K resistor there. So in it goes, holding it in there. Ah, you retracted the message, but I managed to read it. Yeah, it might be. Yeah, as I said, I don't exactly have the chip in front of me, so it could be that it's not possible with the regular tip. It's but I saw some miracles, let's say. I'm not really a good expert on this. Yeah, so if it's a small, of course. But some people, they are really crazy in a good way, that they can really hand solder basically anything. They take up so little wires, like just a few 10 of microns thick, and they simply solder it by hand. So I don't have that surgical hands. So yeah. So now we are slicing. So here we have 2 times or 3 times 2. Aha. So you are also deep into electronics. Nice. Yeah, you mentioned not very everyday expressions here, VLSI and stuff. Just to clarify, I'm not a super expert in electronics. I just find it fun to do it. Aha, I see. That sounds very interesting, actually. It's very, very interesting. And in the 90s, I was in the kindergarten, so. I'm pretty sure you could just brush up your knowledge within a few days. Then you would remember everything. But yeah, it's just, it's like doing mathematics. If you don't do it like basically every day, you really just forget it, and you cannot solve an equation because you just don't have the routine. Almost done with this, and we need 3 for that one there. And then I will need pins on these sides, which is like 14. Wow. I'm not sure if I'm correct, but it seems like I managed to order just the right amount. Yeah, of course. As we get older, we forget, but still, like the videos that I'm learning from here on YouTube, electronics, those are not the guys in their 20s or 30s like I am. So yeah, if you keep yourself active, I guess you can more or less retain what you have, or at least just lose a little as possible. So zooming in. Oh yeah, it's a very good resource, and yeah, I like it because of the format that you can learn both like visually and also by listening to the presenter, and I think that's a very good thing. It's like, yeah, a free class at the university or wherever, or whatever topic you are listening to. So but I'm also a bit I don't know if I should say old-fashioned. I like to read. So when I stumble upon a nice article or something, then I'm glad to read it. That's why I also write my own articles as well, because it's nice. It's also a nice format. But yeah, I think people underestimate how much knowledge is available on YouTube. They just don't really know how to use it, or I don't know. And yeah, I'm defending my channel format a bit, but people often don't like longer videos. They think it's a waste of time, but imagine when you are at school, you are sitting at the class for at least 45 minutes and you have to listen. So sometimes if you listen for a whatever, like I have 30-minute videos or 1-hour videos, it's just literally one class. So it's not too bad, I guess. Or yes. Yeah, I don't want to, let's say, offend my potential viewers. So yeah, but you wrote it, not me. But yeah, I agree with you. Yes. I mean, it's really, at least my principle, I'm really liking longer videos. I have several channels that I follow, and they produce hour-long videos. And I'm just happy to watch it because within 1 hour, they just spread so much knowledge. And also, I try to make my videos that way, that I'm not super smart or whatever, or not sharing like super informative knowledge. Like, I don't know, I don't tell you how to build a car from scratch, but like how to build this and what is the design principle and stuff. I think that's, if you are interested in this topic, so as you mentioned, if you are my target audience, then I would say it's a pot filled with gold. So yeah, those people who cannot have the, let's say, 1 hour attention span to literally get all the information for free, then yeah, they deserve something else. Or, well, they don't deserve anything. But yeah, it's good that you wrote these things. It's always nice to hear others' opinion because, yeah, it helps me improve my channel, obviously, and my content. But yeah, I won't name channels, but there is a very popular electronics channel, few million subs, I guess, and that is really just a sensational videos nowadays, just to have the views every week, but not really knowledge. It used to be a very knowledgeable channel, in my opinion, but now it's like not too good. So that is like, that person tries to serve the market, which is good for his wallet, obviously. And since he's a full-time YouTuber, he has to do it, but I'm not a full-time YouTuber yet, I guess. So those are in. Yeah, why I put these plugs here is very simple. I will just have jumper wires, or whatever they are called, like these guys. Oh, I hope you won't unsubscribe me. I still have 20,000 subs left, but oh, I mean, obviously I have to sometimes show sponsored content, but just it's an advertisement for like 1 minute. But that really helps the channel. But otherwise, I don't want to make it in a way that the channel itself makes the money. So for now, it's not profitable for me. Yeah, of course. I mean, we should not deny the fact that more money is just better. So yeah, of course. But I want to, let's say, build up other channels to make money. Let's say by building these boards and monetizing these boards, sell them through my web shop in the future and stuff like that. So that's the plan. I don't know that channel, but I will look it up. I will look back the chat after I finished here, and I will definitely check it. But yeah, of course, we have to support ourselves somehow. And so far, I've been doing this from my own pocket, but yeah. Yeah. No, I will try to maintain a more or less good behavior. So, for example, I try to respond all the comments as long as they are not personal. But otherwise, I try to be very communicative. And yeah. But I don't want to change my topic here. I want to build stuff which are fun. And just want to show it to people and want to show them how to do it, how to build it. But I don't want to, I don't know, become a sensational channel or whatever, which is just producing more money, but it loses the main purpose to actually make people interested in this stuff. Zoom out again. Oh, thanks. Yeah, I try to. That's actually from day one, because I was annoyed by some channels that they don't interact at all. I have another channel which I watch from time to time. I think actually that guy will upload his regular video today. And they don't interact, or they just interact with the people in the first 2 hours. And that's that. And then what's the purpose? And I received a comment today. I'm still about to, I still have to answer that. I have another old video. And then the guy was even apologizing for having a late comment because the video was like uploaded 2 years ago or something like that. But in fact, that's the purpose. I try to share something, then I take the responsibility for the video, and whenever there's a new comment or question, I try to answer it. So yeah. So I hope other people will notice that I answer them, and then yeah, they subscribe or share my channel or whatever is the good practice nowadays. So we are getting there, actually. Half of the board is done. I need a 4-pin header. You mean these guys here? Yes. I don't remember from the top of my head, but I remember that there is something up with these in the exact same topic that you answered. And you know, when you open the datasheet, there is this summary about the features One is which makes it silent, and the other is, I think it's the stealth chop is one. And then there is another feature which this Trinamic has whatever patented or use it as their own feature. And yeah, whatever. The thing is that they are kind of mutually exclusive, but I don't exactly know the reason behind it. But I know that you cannot use them together. But yeah, the soft homing is actually what happens there. So when you drive any type of motor, electric motor, you have this back EMF. I guess you know this because you work with electronics. But yeah, there's a back EMF which you can actually measure. And then if the motor stalls, stall guard, I think that's the other feature. So the stall guard makes sure that if the back EMF goes beyond a certain value, then it stops the motor basically. So actually you can use this soft homing through this feature, and that stall guard is somehow a bit, how to express this? So that stall guard cannot work at the same time as the other feature, the stealth chop. But I don't remember what was the exact reason for that. But yeah, there is something in the principle of the operation which prohibits it. Yeah, I need to read up on that because I don't know it from the top of my head. I just remember that, yeah, there was some conflict in the features or in between those two features. And that's why it was not possible. Yeah. So that feature is, yeah, when the motor crashes into, let's say, the end of the rail or something, and then this stall guard continuously monitors this back EMF. And then by listening to that, then actually it can stop it. This should be enough. I will actually use that in a future video. Actually, if you are still here, I have this. I have this thing, which is my development platform, which is based on a TMC 2209. And I still owe a person with an explanation of how to torque control the stepper motor. And the secret is in this, in one of these fancy features, because it allows you to monitor the current for the coils of the stepper motor. And then by monitoring the current and looking up the datasheet of the stepper motor, you actually can calculate the torque. So these pins that I'm installing now, those are for the limit switches. I will try to find a limit switch in a moment, which is compatible with this board, or in principle any limit switch is compatible as long as you know how to connect it. And actually you can see the polarity, so plus, minus, and S as signal. So you can just use whatever limit switch you want. But a specific type of limit switch, popular limit switch, has this kind of pin arrangement. And then I decided to use it with this board. Oh yeah, give me a moment. It's this limit switch. It comes on a module, it's installed, and it has this pin layout. Plus, minus signal, red, black, green. So it works directly with this. So that's why my board looks as it is, as it looks. Yeah. They always like to use fancy words. Back EMF is just, yeah, it's a backwards voltage, basically, yes. But yeah, it's more technical if you use the fancy words. But yeah, I guess whenever you want to publish some papers, especially those technical data sheets or white papers, you want to use those fancy terms to sound professional or whatever. I'm just joking a bit, but yeah, it's just a fancy word for the voltage which kind of goes backwards towards the driver. We can call it that way. Actually, where I encountered EMF, that was physical chemistry. So it's not even electronics first. But when I studied physical chemistry at the university, then I heard that expression. And I was like, what is this? And then they said, yeah, it's voltage. Yeah, okay, cool. So we are approaching really. This is almost done, actually, by the way. So, but far from finished, but it's almost there. You will need these pins to see. By the way, look at this cool text. It's almost an IKEA stuff. It's even blue. So, yes. Done. Yeah, it's electromotive force. Yeah, that's what we were discussing. And yeah, welcome here. Join the discussion. Feel free to criticize my soldering or my English or whatsoever. I'm just trying to have fun. So yeah, it's free speech as long as you don't talk about forbidden topics, I guess. That's not me, but YouTube. Who will a little bit shaking, but I just haven't had lunch yet, so probably the low blood sugar also contributes, but yeah. So now these are 100 microfarad and 25 volt capacitors. And the data sheet of these trinamic drivers now I try to avoid let's say strange topics and stuff. Obviously I have opinions in things, but I kind of cannot afford losing my channel and stuff at this point. I don't really want to. But yeah, sometimes this free speech or whatever it's called, it's a bit strangely defined. But yeah, so these capacitors is for the VM pin down here, which is just a filtering capacitor for the driving voltage. It's not the IO voltage, the 3.3 volt, which is up here. That is the VM, which is the motor voltage. So going back here, first I will solder this DC barrel jack here. Now this will take up a lot of solder, so I first just wet the solder, and that is because it will heat up this pin better. And then that's that. And one more here somehow. That's good enough. That's good enough. There. That doesn't stick because I was clumsy. Good. Honestly, I don't know if it has any kind of ratings requirements, but I've been using these caps with this circuit for quite a while, and I haven't had any problems so far. And as you can see, I purchased the wrong radius because the footprint is actually larger, but yeah, whatever, I guess, as long as it works. So there's one solder that I'm not really satisfied with, but later on I will fix it up. Yeah, exactly. If it works, it ships. We don't need to overdo things, right? It's as long as it works. Yeah, so now we have this part here, which is nah, not rocket science, not yet. We are not there yet. So then this module has to be a bit modified. So this is a DC-DC converter, and it can be regulated by these resistors, including this variable resistor, or potentiometer, and then the secret is in behind here. So you can see, I will try to get something here, is there are tabs here for different voltages, and they are not shorted, but we can short them by soldering them together, and then it will provide these voltages or electromotive forces, just to keep the expressions fun. So yeah, then in addition to that, to solder these one of these blobs together, I will need to cut this trace here, right here. So then it disconnects from the other pin of the variable resistor. So that I don't know how much I can zoom in, but believe me, I'm doing it. It's just a bit far away, but let's see. So first we make an incision here. Somewhere here. I don't really know. This is clumsy as heck, but I think we made it. And now I have to solder together the 3.3 volt part. So let's do that. Yeah, thanks for the feedback. Yeah, it kind of zooms, but I can see that the resolution is horrendous. But yeah, you still can catch the things, I guess, to some extent. But it would be nice in the future. Maybe I will have some better camera setup. This is literally my first live stream, and if the format works, I will keep doing it. But as of now, we do it minimalistic. It's just the phone. I could barely start the stream because it was complaining about the rotation of the video or orientation. And I had no idea how to fix that. So now I zoom out just to have a sharper image. Yeah, so there's the blob. Shorting out the 3.3 volt, and I hopefully this connected those by cutting it. I just check it now. Must be fine, but I can try to cut it a bit more. Yeah, this feels fine, but I will measure it in a moment. Another soldering first. So another trick what I use typically, let's see. So now I want to solder this in a nice way. So I take a 3-pin header here, and then insert it here. Oops, that's not how I planned it. And then put it in the breadboard. Aha, thanks. Yeah, hopefully it's going okay-ish. Now you see, I use this glue again. Now it's firm, you can see. I can actually make this a bit more. Wait, I'm reading your message. Just a moment. I didn't catch the beginning because I didn't know when it was going to start and was watching another video. Oh, sorry. Yeah, I literally just decided, okay, let's go live. And I did not have any prior plans. Aha, yeah. Yeah, I was talking about the pin header, not the other. Yes, but yeah. Next time I will plan it better, and yeah, if this format works or I get other feedback that this should be changed or whatever, then in the future, now as you gave the feedback, I will announce these live videos maybe a few days prior to the live stream. So then people can, I don't know, prepare. So yeah, but yeah, of course, I will announce it in the future. So yeah, sorry for the inconvenience. Now what I have to do, I have to test this thing. So let's do that. So we have some clips here. And then once this finds the brightness settings, so in plus, there we put our power supply. And then we have a GND in the middle. And then, be right back. With a voltmeter. So that should be it. And then now, yeah, I just first turn it on. Okay, no short circuit. That's nice, I guess. And then the negative is here. First I measure if it gets the input voltage. Yeah, 12 volts. So now I switch. This is not the most stable setup here. Wait, I'm just extremely clumsy. Yeah, 3.3 volts. It works. I want to check this because this will be soldered directly in the board. If I solder in something that doesn't work, then it's just wasted time. So yeah. This goes back. And then again, this has to be lifted by a few centimeters, a few millimeters only, not centimeters. So you can see there is a small gap. It's okay-ish. Now I don't bother with that holder. And then soldering again. It's good enough. Yes. Yeah, so I guess the board is done. but my work here is not done. Now comes even more annoying parts. Hope you can survive it. So we have the TMC 429. We have a TNC 4.0. Yeah. What else do we have? Yeah, I have these. And actually, let's talk about this. Actually, I mentioned, maybe that was the beginning that you missed, but in my previous video, I made a microscope stage controller, and which is nothing else, is that it has a microcontroller here. That is a TNC 4.0. And then that communicates with a ramp generator, this guy here, TMC 429. And that ramp generator then sends out the driving signal to the three individual stepper motor drivers, the TMC 2209s. And they control three individual axes, X, Y, and Z. X, Y is a microscope stage which moves in the XY plane. And then the Z, in my case, is moving the whole column of the microscope up and down, so I can use it for focusing. So this is, in my application, it's a microscope stage controller, but this can be just basically a 3-axis stepper motor controller. So any type of 3-axis mechanism you build, you can control it with this board. And I used this ramp generator. So yeah, it's like a ramp board. Yeah, kind of. Yeah, actually, you could use this for a 3D printer even. And, so it's, as long as you can program it. And that's why I chose the TNC 4.0. One, the friend who wants to have this board wanted to stick to that microcontroller, but also it's a very powerful microcontroller, and it has a lot of I/O pins, and then I can use it to really control everything here. Plus, since all the pins are broken out there and there, we can attach even more hardware or peripherals to it. Yeah. Anything. You can add anything extra, so it's broken out. And I think you asked these questions. Now, if I remember, it was you who were asking about these things under the video, isn't it? Because I remember you from some comments. Yeah, it was you then. Yeah. But yeah, I broke out all the pins and everything. So even if you want to do some extraordinary stuff, it's possible with the board. So it has its purpose, which I wanted to have. But if you want to add further extensions to it, then yeah. Oh yeah, now you know. Now I told you. But yeah, everything. You can see that, yeah, the microcontroller will sit here, if it zooms or if it focuses, in this header, the female one. And then the male one still makes all the pins of the microcontroller available. And then you can also connect everything here for the TMC drivers. Plus, I have 2 pins left over from this I/O module, which I added externally or additionally, P6 and P7. So those are also broken out, so you can use them. And since in the future I want to have a simple display just to see the X, Y, and Z positions, here I made an I2C breakout, which will be used for a display. I have a large OLED display, 2.42 inches or something like that, if I don't remember correct, or if I don't remember wrong. And I want to use that display to show the current status of the board. But yeah, coming back to this, I show it on this. I did this rather than using a RAM board. The cocky answer is just because I can do it. But the honest answer is that I wanted to build it for myself, for my, let's say, custom application. And also by the process I designed this board and understood all the parts, I learned a lot. So typically, so yeah, it's partially I did it because I can do it, or I was hoping that I can do it, but apparently it worked out well, so I could do it. But I wanted to have more freedom and customization with these things, and this allows me a better freedom. So yeah, flexibility, learning, and then yeah, why not? Because I did not know too much about these boards in the beginning, so then this was a good learning stuff. Yeah, also microcontroller. That it's a very strong microcontroller with a lot of peripherals built in. It has multiple serial ports and stuff, which is actually very useful in this application. So, and it has a lot of memory, so you can upload whatever code you want. You don't need to write a very efficient code. So whoever is watching still, we have these 3 tabs here. So this board actually has a serial port because you can communicate with the chip via the serial protocol. And that's what I do. That's how I configure the chip. Yeah, SPI. But this is more the TX-RX type of SPI, not the MOSI and MISO and clock and stuff. So you just need the TX and RX pins. So this has that kind of serial peripheral interface, the, let's say, regular one. And with these tabs, you can select which pin should be the SPI pin or serial pin. So in my case, if I hold the board this way, yeah, these acronyms are crazy. They drive me nuts. If I hold it like this, you can actually see the traces if I hold it at the current angle. That there is a trace here coming from the right side tab. There's a trace here coming from the left side tab, and actually the middle tab there is connected to one of these pins on the actual chip. And what you do is that you have to solder together one of these in order to put the serial communication either on this pin or the pin next to it. And this modification has to be done because my board is not only compatible with these are original but crazy expensive, like 10, 12 US dollars TMC drivers, but my board is also compatible with the AliExpress version. I will try to get them. These guys, and these are like 5 times cheaper than than this guy here, but they also have their SPI pin on a certain pin, and actually they are even more difficult because you have this resistor, which is actually a 0 ohm resistor, and you have to shift it if you want to shift the position of the serial pin. But yeah, I digressed. Coming back to here, so if you hold the board like this, so the chip is upside down, the capacitor is on the right side, and the variable resistor is on the left side, then you have to solder it that the blob is on the left plus the middle. I did that already, I think, on one of these. Yes, you see it. So the blob is like that. Then it's compatible with my board. So I will do it on those 2 other boards where I don't have it, but this will be a nightmare because I was so genius that I already soldered these pins in. So yeah, that was a good decision. I was ironic, but yeah, this has to be done to have everything in its proper setting. So now I zoomed in, so you have potato resolution, but it should work. And how to tackle this? Let's see. It should be this. So now I flip the board 180, so it's the right side plus the middle. So just kind of preheat the board. There, one is done. Success. And then, no, this is still the same tip. I haven't changed the tip. So here I will suffer a bit, but whatever. So this is the normal, or normal, for me, it's the normal, very pointy tip, but it should work. So let's see, how am I going to do this? That's a good question, right? Success, I guess. Let's do a quality control. Yeah, I managed, and I did not melt any of the plastics. And this is also there. So blobs are good. We need this. And I should have 4 more of these. Or 2 more. That's not the one. Yep. Yes. All right, so soldering time, I guess. This goes in. Aha. I was looking for the chip, but I actually had it. It was very professional. So let's patch this up. Hopefully you see it. All right, so this is done as well. So they just simply go in the board like this. So there we go. 3 original TMC drivers. Nice. Another bag of these. Another original TMC 492. So now I will need pins. So I zoom in like this. And then this will be simple. Just and 2 more. Maybe I don't cut this, but grab something from the garbage bin. Right, let's cut this. So the chip should face upwards, and then first we start with the 10 pin side, like this. Should be good enough. Just let's do it. So now this driver, how it works, actually it has 2 modes. One is a serial mode, or this ramp generator, and it also has a, let's say, step direction mode. And I use it with a step direction mode. And what it means is that instead of communicating with the stepper motor drivers via serial, obviously, it communicates by sending step and direction signals to it. So I just insert this in advance. This will be my template here, or like a jig. Now I need to adjust it. Sorry, look, behind the scenes. And actually these pins which I'm soldering now says ref R2 and ref R3. Those are the right side reference switch pins, or in a simple term, they are for the limit switch for the right side, because they, for some reason use the right side and left side as like reference directions. So done. Ta-da. Okay. We have a microcontroller. There, or it's not there, it's missing from there. But I promise you I have it. So again, we need a bunch of pins. Let's go with white, just for fun. And again, insert, insert, and insert, and solder. That's simple. I see something on the board which I will bring up in a moment. As I managed to solder everything. Let's go for this. I actually have a fume extractor, but it's a stupid loud. So lung cancer it is, I guess. I should not be that bad, but who knows? So I actually want to ask you, was it that chip that you tried to hand solder? Because this seems to be like a small 6-pin chip, which seems to be quite difficult to solder. This is what I wanted to ask. Because initially I was thinking about this chip. That's why I asked if it has 3 or 5 pins, because sometimes this kind of size has 3 pins on this side and 2 on this side, and that's sometimes an op-amp or a voltage reference. Yeah, this one. Yeah, this is tiny. Yeah, you are in the US, I guess, but since you work with these things, you know metrics. This is there 4 millimeters. So yeah, this can be pain in the ass to fix. There you go. And then the other side is like 2 millimeters or so. Let's see. Yeah, 2.5, whatever. I can't even read it. I mean, I can see it, but the precision here. Yeah. Yeah, this is very challenging. Could be very challenging. So no wonder, yeah. Yeah, okay. Now I know the chip because yeah, I had this second type which I showed in my head. Then I thought that yeah, this is actually not super bad to solder, but this can be very funny. But I won't solder it. Lucky me. I just insert it in the board. Now this starts to look nice, right? Quite nice. But it needs another part. This guy here. This is important. Whoops. PCF 8574N. This is the GPIO expander. I2C chip, very simple. It has 8 GPIO pins. You can address it, so actually you can daisy chain them up. I will show you in a moment how. And you can have, I think, 64 GPIO pins in total, or 65 devices. I don't remember. 65. Yeah, you have 3 address pins, so 2 to the third power equals 8. Therefore, 8 times 8, because 8 pins and 8 daisy chain devices, you can have 64. 64 GPIO ports in total. Now this seems fine. All right. Regarding daisy chain, give me a moment. So these guys, these are the same chip, and you can buy them on AliExpress. Actually, you can visit my website. There's a parts and tools page where I publish this, so you can even support me. But yeah, whatever. You can chain them up like this, and you can chain up 8 of these on one I2C bus. And then you can adjust the addresses here for each unit. And then you can have 64 GPIO pins in total by just using I2C, which is 2 pins, SDA and SCL. So if you have an 80 tiny microcontroller, then you can expand its GPIO ports to like whatever 64 GPIO ports in addition, because of this possibility. So now comes the fun part, and I hope I did not mess up anything. I have this naked DC barrel jack, and I will have to check which is the positive, but I think this one is the positive. This center positive. And then I drive this with a power supply, because if everything works, then this LED should blink, because I was cheating a bit here. You could see that I removed the board from this package and from this package, but I actually programmed it with my program already and put it back to the package. Nice, right? So then now I can test the board if it works. So give me half a minute just to check everything. Hopefully everything works. Yes. I'm just making sure that the polarity will be correct. So yes, power supply, positive and negative. And just to double check this, I don't want to take risks here. So it's in continuity mode. And I grab whatever ground here and I check this. So it's shorted to the ground, which means that this is the ground pin for sure. And it's not shorted to the 3.3, but if I measure here, this is shorted to the 3.3. So that's fine. And this should not be connected anywhere because it's powered from the USB. That's how we want it to have this, because it will be always connected to the USB some way. Either because it's always connected to the computer, or we will use the USB as a power supply for this as of now. So that's fine. Let me see here. Fine. Just to double check. Good. Okay. It seems like that the power rails are not shorted. So first we need to power this thing. I just go gently. 100 milliamps just for a very short time. Let's see. And then I will also need this as an external power supply. Again, another, not an ad, but it's funny that IKEA actually has very decent power cords, USB cords. So yeah, that's that. Just clean up these things. Okay, so wish me luck. I power on the board. Okay, 25 milliamps. And you kind of see it. That's blue and that's blue, the LEDs. And now you should try to see this LED as I connect this thing here. It must do something. Oh, yep. Ha! Ah, the board works. It's blue, which is the standby color. So yeah, the board is done and it works. How cool is that? No? Yeah, that's a very good question. Thanks. Why there is no pins, or why there are no pins here? So this I will just send it to my friend. And he will actually connect the stepper motors himself to an enclosure or whatever he will use. I mean, to a terminal attached to an enclosure. So therefore I asked him in advance if he needs terminals or connectors for these. So yeah, that's very good. Very, very good. Thanks for paying attention. But yeah, I haven't mentioned this, but he wanted to not have these in order to have them connected the way he wants. Otherwise, if you give me a second, I would use these very popular JST connectors, if I could fish them out. So on my other board, I actually have them like this. I just show you one example. It's a bit, yeah, the contrast is not too good, but yeah, you see it, and I guess you believe me that that's a connector. There. So that's that. And then, of course, have the stepper motor, and then it has the counterpart. But that's my product, which I use at home by myself, but this will go to my friend, and he will use it in his enclosure, and he will connect the stepper motor wires as he wants. Max maximum board amperage. You should not use this as supplying power to anything. However, I made a power breakout here if you have a display or something. So if you have a display or those things, those are cool and fine to use. And this driver, to be honest, I don't remember exactly, but either 2 or 3 amps at 3.3 volts. I can look this up in a moment. Give me a moment. So this is the MP2315, 3 amps. 3 amps, 24 volts device maximum. I guess the 24 volts is the input voltage, and the 3 amps is the output current that it can provide maximum. Yeah, it can continuously provide 3 amps. So almost 10 watts at 3.3 volts. Nothing will need that. Now, split between the stepper drivers. Or are they separate? No. I get it. No, what I talk about is only the logical voltage. So that voltage or current which powers this guy here, or powers the chip here, or provides the 3.3 voltage to the boards, those are 3 amps. But actually the board itself, I've written it here, 24 volts. And then you need to have, I think these are 2.8 amps per part. And I have a very thick trace going to the positive. That should be able to carry the current which is needed by the boards. So yeah, there's a thick trace. Where is my pointer? Coming right there. And then that goes over the edge here to each motor power individual. So yeah, that is directly connected through the capacitor, or not through the capacitors because it's not series but parallel with the input and the ground, positive voltage. But yeah, so here we have 24 volts and then 6 amps maximum, I guess, or a bit more, maybe 8 amps, but they never take up that much current, so that's not a problem. But yeah, DC barrel jack, input goes in, input power, part of it goes to the DC-DC converter, and that powers the logic part of the chip. 75 watts, yeah, but that is like you run everything to the maximum, so that will not occur. I would say 10 watts maybe, or less, because actually if you when I draw my XYZ stage, I could not see more than 1 or 1 point something amps taken up. But then I ran the motor drivers individually. So first moving by the x-axis, y-axis, z-axis, so on. So it was a serial running. Yeah, then it will be closer to 75 watts. Yeah, I can Google this. Just give me a second, because I just don't remember the TMC 2209 current. Yeah, it's a 2 amps RMS per driver. So then it's 75 watts, yes. Because 72 watts for these, and then that the other 3 watts, let's say, goes to the rest. So yeah, that's it. Now actually I have something more to do here. I have this guy here. I have these here. This. And then and there is an even more exciting part coming in a moment. And then the less exciting part, or yeah, I have to wire everything. So we have two switches. One switch will come here, this J bug, which means actually joystick, button, USB, and ground. So you can choose between 3 modes for this board. It can be a standalone board, and then you can control the stepper motors with this stepper motor driver. What am I talking about? With this joystick in the standalone mode. Or you can use buttons, which is like up, down, forward, backwards, or plus, minus, or however you define them, and drive the stepper motor drivers with buttons. So that's the B. The U is when none of these hardwares or peripherals respond to anything, but then you send USB commands to the drivers and they do whatever they have to do. And this switch allows you to select it. It's a 3-way on switch. So 1, 2, 3. So that's one switch, and that's what it allows. So there's a mode selector, and then you can select the X, Y, Z axis. So another switch, because if you move it with a button, obviously we just have 2 buttons. So you have to select which axis you want to move. So with this on switch, again, you select one of the axes at a time, and then you press either the plus or the minus button. So the axis will be moved forward or backwards. So that's that. And then we have the 2 buttons here, which I already mentioned. So they are like plus, minus, or positive, negative, so on. Yeah, you know, opposites. And then a third button is there that comes here, because there is an abort or a stop button. So this will be used for it. And these switches are fantastic. I don't know if it shows anything. You can see the numbers, Japan. So it's a Japanese button, and you can really feel on the quality, like how they press and everything, and then all the plastic and everything is just such a high quality stuff. They are expensive, but this project really deserves it. So then that's that, and we have the connections for the joystick X, Y, Z. So that's like we have Y, we have X, and then Z is rotating this thing. And you can see that the Z axis is already wired, so that's fine, but these are not. And this is a very nice joystick actually, because you can see that you can adjust the position of the potentiometer with a screw here. So actually you can, yeah, position it properly and set it to a proper 0 point. And that's both for X and Y axis. And actually you can do it with the Z axis as well. You remove the cap and there is some screw mechanism under this, and that allows you to do it. And then it has this dust cap together with this mounting ring, and it actually came with 4 screws. So that allows us to screw it down. And then, so yeah, the least fun part is that we have all these crimps, and we have all these housings, and I have this, and this, and this. This one is garbage. I just use it to cut plastic and legs, but this, it's broken. You can see the tip, but yeah, this side cutter is good. So yeah, now the big question is, should I continue the video while making the wires? Because this is boring as heck. So yeah, and of course I have a bunch of cables. to connect everything up. So let me see. Aha, thank you for joining me for such a long time. It was a nice discussion. So I hope you will have a nice day. I guess you are also in the US. So I don't know, 8:40 there or something like that, depending on which coast you are located at, or you are in the mid US. But yeah, here it's almost end of the day, or it's getting 5 o'clock. We'll do it in the future, 10:30. So you are 6 hours, yeah, East Coast, yeah. So then you are closer a bit. Because I know that the Pacific time is like 8 hours from here. I'm running by Central European time, I guess, you know that. And then, yeah, East Coast is 6 hours. So you still have the whole Sunday for you, I guess, which is nice. Yeah, I'm in Sweden. Have you looking? Give me a moment. Do you mean these guys? CH32. I have projects. So I'm very well prepared here. I have even more. I just need the time, but I have the programmer. I actually have several of the programmers. I have different chips because I want to design some circuit boards with them. So yeah, you see now the packaging. So you can see that I'm not bullshitting here. It's CH32. So yeah, I have looked into them. Very good, right? But I just did not have the time to really dedicate some more attention to them and do something actual fun with them. I'm thinking about more like small devices which you want to drive from a battery. For example, a thermometer or things like that, which can be also decoration at home and some other similar devices. So I want to use them in that because they are cheap, so they can be mass produced for a cheap price, and they are also tiny, because I have some other board designs or plans where I want to use a tiny. Yeah, they are totally legit microcontrollers, and they can be used. But yeah, it just takes a lot of time and effort to look into them and learn how to program them. I started to look at the developing environment, the IDE. That's also, yeah, it will take some time to learn it. I can write code in or at a reasonable level, let's say, but I'm not an expert, far from it, very far. So I have to learn how to do the things. Yeah, yes. Yeah, actually now, as you mentioned memory, that was one of the reasons why I was a bit discouraged by these chips, because they don't have super large memory. But if you choose the correct model, then they also have enough memory. Not with this. It just splice it up in advance, so I can is this? Yeah, again, my knowledge is not that good with these microcontrollers yet, so I don't know how they handle the memory, but their internal memory is very tiny. But yeah, maybe they have something external, like yeah, or you can attach something external. But really, I'm not educated at this topic, so as of now, I'm the wrong person to ask, unfortunately. But I will learn about it, and hopefully we'll be able to tell more in the future. Now I'm just thinking about, I don't know if it's only you or anyone else is watching, but if someone else also watching and doesn't have to run, and if they are interested in crimping or whatever, then I can stay. Nah, then you have, or you should have the time for to read, at least, or patience. Or I noticed that older people, I mean older is just, I don't mean they are like old, but older than, let's say, a 30-year-old. They are better with reading, so it should not be a problem. Ah, I see. Yeah, then do it immediately. You just read it and do it, and then you don't need to worry about forgetting stuff, because you have it in your head, or you have it in front of you. Why don't I use ESP32? Yeah, again, I started with Arduino, and then I moved to STM32, and I don't only use the STM32 with Arduino IDE, with this STM32 framework, but I also use it in the Cube IDE. So I used the HAL framework for the, or not framework, yeah, it's a framework for programming the STM32 boards. So I already learned like 2 different kind of microcontroller families, let's say, and I just did not want to involve one more. So yeah, that's why. But as you ask, I have projects with ESP32. This is a Lolin32 microcontroller. It's just in front of me because I have some work with it. So it will come slowly, but I'm just simply not into IoT stuff. Yeah, I have to see, but it's just there are too many interesting stuff and too little time. I mean, this I just do it in my free time, which is very limited, so that's not the best. Okay, for signals, we go with this. Yeah, as I said, I'm not really familiar with ESP32. I mean, as long as it goes with just programming it in Arduino, that's fine. But yeah, I don't know too much about the hardware, so I cannot really comment on it. But in addition to that, I have no idea what Clipper is. I think it has something to do with 3D printing, because I see it on Reddit, for example. People talk about it. but I have no idea what that clipper is exactly. I haven't paid attention to it. And one more. The disadvantage of these things is that I cannot pick them up with a magnet, and they stick everywhere because of the static electricity. Yeah, so crimping. I will do this for a while, but I might slowly shut down the stream, but not yet. Don't worry. But I don't have too many viewers, and I'm basically just talking to 2 people, so this might be even less attracting to you guys. So I'm using this kind of crimper. Probably some people will say that this is not the correct way. Yeah, anytime. Feel free to contact me, and feel free to leave comments. Actually, that helps. If just leave whatever comment on my channel. It improves the chances with the algorithm and stuff. So yeah, but thanks for hanging around, and I hope you will have a wonderful Sunday as well. If you have a nice weather, just go out and enjoy it. It's good to have some summer. Yeah. See you later. Thank you once again for joining. So yeah, this will work. My gloves are getting destroyed, but for now we keep it. These are not the highest quality crimps. But the results are good, at least. Now I need this. The other day I was looking at some crimping tools, and again, it's not an advertisement. There's a Japanese brand called Engineer. They have a crazy set of different crimping tools. Their price tag is also quite high. So like one crimping tool is about $100, if not more, US dollars. But it's still cheaper than the JST, the official JST crimping tools. They can be several $1,000s sometimes, and I'm not even exaggerating. But yeah, I don't know why they are so expensive, but I guess it's because of the precision and stuff. But come on, it's there's a limit. So we need 3 more of this. I'm just going for good enough. Obviously, they are not perfect whatsoever, but kind of work. And I'm pulling on the terminals just to check if the crimping was enough. All right, so this is fine. Zoom in a bit. Maybe like this. So now I have these buttons here, and they have 2 pins. So I use these guys here. So then we have a red button. So I will put the polarity in a way that I have the board and the positive pin is always on the top, and I want them to align properly. So let's say they should be like this, which means that the arrow is always the positive, which I will mark with one of the colors. So this goes in, I hope. I clicked in, and then I pair it up with the black. Done. This will be the red button. And then another. So again, search for the arrow. This goes in, stuck. Stuck. This will be the white button. And then this will be our black button here. Done. And now we need to solder it. So I will make this simple. So that's there, the button from the back. And since the button just shorts together basically 2 terminals, it doesn't matter how I solder this. The button doesn't have any polarity. So I have the white button, so that will be the yellow cable. Just easier to grab it. Then let's solder it. So now that's what we have. So just snip off the excess wire. Let's see. Done. I could have used heat shrink tube, but it doesn't matter here. So it's a good enough connection. So that's done. And then it sits there, but this was not sitting in properly, so I just check it. And now it clicked in. I'm just fighting with this thing, trying to fix this. Yep. How nice it is. Now it's done. Okay. So this one is the black. Again, good enough. Finally, the red. Let's come and fix this. we have buttons. So this is done. So now we have these two switches left, and we also have the joystick. But it's not only that I need to wire the joystick and the buttons, but they need to be crimped and stuff. But the mode selector switches are a bit more difficult because I have to have 3 wires which go to the board, and then 2 or 3 wires, I don't remember exactly, but I have to short these pins in a certain order so I can use it properly. And then here also I have to solder on this side and then crimp on the other side of the wires, and then the board will be complete. But I think for now I stop here because it's getting very long and I need to take a little break to eat something and stuff. So yeah, but visit my website because this project is already there, published in a very detail. So now I'm just assembling the same stuff again. But yeah, please visit my website. And also there are other more information on my website and also on the YouTube channel. So just look around on my YouTube channel if you're interested in anything that I'm doing. And if you really want to become extraordinary, you can support me on my Patreon page. I publish all my source code and more stuff there, which might be interesting for you. So it could be a good trade-off to support me there. So I hope you liked this thing. I might make this more in the future, we will see. But yeah, for now, thanks for watching and thanks for staying around. And then see you next time.